Hello, everyone. My name is Kaylee Burdett. I'm the event manager here at OCP. Welcome to our OCP webinar, Shell Integrated Immersion Cooling Solutions for Data Centers. We are so pleased to have Shell with us today. They are an OCP Platinum member, and we're excited to host this webinar with them for you all. Before we get started, I just wanted to let you know that this webinar and the Q&A session will be recorded. So we will be providing that to everyone after the event. If you missed anything, you can go back and watch it that way or share with your colleagues. If you have any questions while the presenters are speaking, you can enter them in the questions box that you'll find in your GoToWebinar control panel. And then I'll read them aloud for the presenters to answer following their presentation. I think that's everything I needed to cover with you all, so we'll go ahead and get started with Eduardo and Sandeep and enjoy their presentation.
Okay, so good morning or good evening, everyone. So the challenge we face as a result of the climate change requires a fundamental shift of thinking and cross-industry collaboration. So many thanks for the OCP for organizing this webinar, where we are glad to introduce to you the Shell integrated immersion cooling solutions, enabling game-changing energy use reduction at data centers. Okay. My name is Eduardo de Azevedo, and I'm a product application specialist at Shell Global Commercial Technology, based in Hamburg, Germany. I'm currently leading the R&D efforts of the Shell Immersion Cooling Fluid for the data centers and the synergies related to the material compatibility. It's my pleasure to be here today with you. I would like to introduce also Sandeep.
Thank you, Edu. Hi, everyone. I'm very happy to be here. My name is Sandeep Kamath. I'm the Global Marketing Manager for Shell, and I lead our marketing efforts for process oils, for immersion cooling fluids, and also for our EV thermal fluids. Right. This slide, there's a lot of words on this slide, but in summary, what it means is, please don't use the information that we share today in our presentation for trading of Shell shares. Yeah, that's all it means. The agenda for today, we'll obviously introduce the topic, then we'll talk a little bit about our integrated immersion cooling solution offering for data centers. Edu will speak about our Shell immersion cooling fluid that we have engineered and formulated specifically for immersion cooled data centers. We'll also speak a little bit about our partnership with Asperitas. Edu will talk about Shell's work at the ACS and specifically the work that we are co-leading in material compatibility, and then we'll open the floor for Q&A. All right, so Edu already referred to a little bit, on the challenge, right? So I think the biggest challenge facing humanity today is climate change. And this is a challenge that no one person or one company or even one country can solve on its own. This is something that we believe the whole of humankind needs to come together and try to crack quite soon, actually. And this actually also extends to our way of life, working with data and emails and social media and internet and moving on to big data and connected devices and whatnot, right? So internet now is the fundamental part of our life. We can't imagine leaving our homes without our phone. It seems like one of our limbs is missing then. But not many people are aware that just the data centers today use about 1% of the global energy, and including the infrastructure, including the networks, that actually increases to 2%. And to give you an idea, 2% is the energy that is actually used by the airlines industry pre-COVID. So that's a big number actually. And we are all aware that our use of data is only going to increase. We are using more and more amounts of data. It was 3G before and 4G and now 5G, and that's only going to increase. So the amount of data that's being generated is exponentially increasing. So the need for data centers and associated infrastructure is increasing, and so is then the consumption of energy would also be expected to increase. But then that is sort of adding to the challenge that we have with climate change, right? So what can we do to meet this challenge while at the same time maintaining our standards of living? The challenge today is we have the need of more and more connected devices, high performance computing, near real time analysis, increasing amounts of data infrastructure that is needed. But the fact today is still most of the data centers and infrastructure is still using air cooling, which is air conditioning. And in very simple terms, what that means is we are using more energy to remove the waste heat that is generated from the data centers. So it's not a really very clean or very sustainable way to operate our data centers. So is there a solution that we can deploy to run our data centers more sustainably, while still maintaining the standards and still maintaining our requirement of more and more data and more high performance computing. So Shell has developed an integrated immersion cooling solution, which we believe can enable game-changing energy use reduction at data centers. So this slide, I'll just talk you through the key pillars of our immersion cooling solution. So you see the triangle here in the center of the slide. The heart of the triangle or the center of the triangle is the immersion cooled server that we have partnered with Asperitas. It is a Dutch company, and they have developed a fantastic server that basically takes all of the electronics that goes into a typical data server and immerses it in their server module in a fluid, and that is the Shell immersion cooling fluid, the top part of the triangle. This is a fluid that we have specifically engineered and formulated for immersion cooling of servers. We have actually co-developed this fluid together with Asperitas, so they have helped us a lot in the last year and a half, to tell us how the fluid needs to perform and what are the characteristics, and helped us with also the testing of the fluid. Then you have in the center, you see the blue part, that is the waste heat reuse, right? So this is also a solution that Shell can enable to reuse the waste heat that is being generated by the server, and the fluid actually enables to do that because you have the electronics immersed in the fluid. So the fluid is a much better carrier of the heat than air. That heat can then be passed on to a closed cycle water circuit, and you can use that then that waste heat for heating of the offices or for hot water or whatever purpose that is required. Then you have the bottom right part of the triangle, which is renewable energy. And Shell has a big portfolio globally of renewable energy services that we can provide, whether that is on the grid through your normal electric connections, where it is available in certain geographies, and we can also provide installations of solar and wind farms depending on the location of the data center and depending on the need. So for example, if it's a sunny place, if it's remote, then probably a solar installation would be good. If it's more of a windy place, then maybe wind farms might be more suitable. And then looking at the left bottom part of the triangle, carbon credits. So here Shell is able to also offer a carbon credit solution. So we are able to look at your entire portfolio, your entire data center, but also your entire portfolio of business, and offer you a carbon credit solution to offset your carbon credits that you have through our nature-based portfolio. So why should you move from a well-established air-cooled server to an immersed cool server. We believe that the benefits are massive, and those we have tried to depict down in the bottom yellow boxes. So we believe, and Asperitas has done a lot of testing on this. So up to 50% of energy footprint reduction is possible from an compared to an average data center, just by going for immersion cooling. Not only that, you can also expect to increase your CPU performance by up to 40%, and that's uh, because the electronic components are cooled in such a good way. They are able to be clocked up to much higher speeds, and so you get much better performance from that. Then if this is taken into account from a design and planning perspective right before the data center is built, then there is a potential to even reduce the actual physical size of the data center, because you can do away with lots of the infrastructure that's, for example, required for air conditioning. That's not needed anymore. I spoke a little bit already about the waste heat reuse solution. So up to 99% of the waste heat that is generated by the electronics, by the servers, that can be actually reused as 55 degrees centigrade hot water. And also there is a possibility of actually reducing cost. So depending on the size of the data center, so the bigger the better, that you can actually reduce your capex and also your opex by somewhere around 30 to 45% versus an average data center build. So overall, all benefits here, and you are actually even making it a more sustainable solution. You are helping towards the climate challenge as well. Yeah, so what can I say? I mean, we really believe in this solution, and that's why Shell is now an active participant at OCP, and we are very closely collaborating with Asperitas, as we'll talk to you on the next slides. Right. So this slide, we have just tried to depict a model of what we foresee, or what our ambition is with the data center build, and the integrated solution. So here, if you look at sort of the center left of the slide, where it's with the tags data center. So this is sort of, let's say, the data center build. So here, if you have the data center build with the immersion cooling servers from Asperitas, with the immersion cooling fluid from Shell. Then I spoke a little bit about the renewable power, and here you see, Shell is able to offer renewable power through the grid, or also through, solar installations and wind installations. The reuse of heat is, basically the waste heat solution that we can offer, where that heat can actually be used to, heat up a neighboring town, or heat up your, data center or your office block, or use for hot water, if that is the need. And this total sort of is a closed, sustainable sort of loop, which we believe is, a much more sustainable solution. And it's also, not, you don't need to pay any more for that. It actually will help you to run your data center more efficiently, with higher performance, and with also reduced cost. Right. So here on this slide, we've just tried to summarize, all of the main pillars or components of the various offers that we have in that integrated solution. So on the left, you will see this black box. This is the server module, which is an Asperitas server module. It is designed for immersing of the whole of the electronics in it. It's a completely flexible solution. It can be deployed even in standard office spaces, although the most bang for the buck can come when this is actually taken into account even right before, in the planning stage of a new data center build, because then you can actually get the benefits of engineering the waste heat reuse and doing away with the air conditioning infrastructure and so on. One of the unique properties or unique selling points of the Asperitas solution is that it is there are no moving parts. So there are no pumps, so that pump doesn't waste any more energy. While because of being because there are no pumps, and because the The whole solution is based on normal convection currents. The electronics are able to actually clock up to even higher speeds, and you're able to extract even more energy out of the system to make it useful. So the 55 degrees hot water that I spoke about, it is completely climate independent. It doesn't use water per se. So you can actually deploy such a data center right in the middle of a desert. It is optimized, for high performance and heat reuse, as I spoke before. And it is designed in such a way that it can be the maintenance can be done very easily, and without any spills at all. So Asperitas also has developed equipment, that can help in maintain in the normal maintenance cycles, and keep it very very hygienic. A little bit about the shell immersion cooling fluid. As I mentioned, we have co-developed this with Asperitas over the last year and a half, and this is specifically engineered and formulated for immersion cooling. And Asperitas has helped us actually to tell us how the fluid needs to perform, and helped us with all of the testing part. So Edu will be talking in much more depth about what are the benefits of our immersion cooling fluid on the next slide. And then lastly, our renewable energy and waste heat reuse solutions that we have offered through the Shell Energy portfolio. So we are able to offer, depending on your needs, power that is on the grid, off the grid, waste heat reuse solutions, and also I mentioned the carbon credits solutions through our nature-based solution portfolio.
All right. Thanks, Sandeep. And this slide would like to focus a little bit more on the fluid itself, and also would like to mention that as Sandeep just walked us through a little bit on the fluid side, and it was co-engineered with Asperitas. It was optimized for Asperitas natural convection driven technology, but can also be used in the pump or forced circulation systems as well. And the Shell immersion cooling fluid is a synthetic single-phase immersion cooling fluid made from natural gas using Shell GTL, which means gas to liquid technology. And GTL fluids have a water-white color and offer a uniform chemical structure, a high flash point, and a low volatility, and an outstanding light and thermal stability. The products are colorless and contain virtually no sulfur, nitrogen, or aromatics that are found in conventional crude oil-based products. And associated to the high purity of the GTL medicinal base oil, we specifically selected the additives to ensure even higher thermal and oxidation stability during the operation. And for us at Shell, as you know, the safety of the employees is the customers and the society is the utmost priority. As the GTL synthetic base oil meets the US and European pharmacopoeia purity requirements and is also food grade certified, the safety of the people handling the fluid is improved. And also the fluid extremely lower volatility and non-evaporating characteristics contributes to not only with a safer environment, but also with sustainability and not depleting the ozone layer. In easy words, to the purity of the GTL, there is nothing, nearly nothing in the oil which can react with the components. Okay. So, as mentioned before, the challenge we all face from climate change requires a fundamental shift in thinking and across industry collaboration, right? And OCP, we see as a leading forum and organization where we have the chance to exchange exchange information, experience with the key industry participants to identify and enable decarbonization pathways and to follow towards a net zero emissions future and more sustainable solutions. So now that Shell is a member, we have the chance to collaborate and contribute with the immersion cooling technologies adoption by the industry. For example, Shell is actively involved in the ACS, the Advanced Cooling Solutions workstreams, focusing on the requirements related to the immersion technology. Shell is also co-leading a new workstream recently created to focus specifically on a database for immersion cooling. For example, this slide was presented last month during the OCP Tech Week event, where we had a great panel discussion with 3M, Microsoft, and Dell about the importance of the material compatibility in immersion cooling developments or applications. We see that this is a complex topic and becoming of one of the most important subjects because of the intrinsic relation between the components and the fluids immersed in the models, right? So through the OCP platforms and the work groups, we are aiming to standardize the main compatibility test procedures adopted by the industry through this collaboration, exchanging experience, good practice among fluid suppliers like ourselves, OEMs, and integrators. And we work with multiple strategic partners and companies around the world. And not only with Asperitas, which we developed, we co-developed the engineer this fluid, which by the way perform multiple certification tests, and there are several deployments up and running at this moment. But also with IT components and manufacturers by testing their components in our GTL synthetic fluid under different operation conditions. And going further, we also are working with polymers and compounders, material suppliers in collaboration for testing and evaluating their materials for immersed applications. Those materials and polymers companies are very keen to work with us to identify the compatibility of their materials for immersion with our GTL synthetic fluid, so that their materials are available in the industry, let's say, ready for this new application field as well, avoiding any surprises during the operation and increasing the equipment reliability. So through this collaboration, we are able to identify any challenge on compatibility in advance. For example, APDM with APDM elastomers, and help the suppliers to develop an alternative polymers or compounds which are more compatible with the fluid. And for example, this table illustrates a guideline based on tests performed at our laboratories. And the components are normally made from different materials and formulations, and therefore the compatibility behavior may differ from each component supplier to the other. And for a detailed investigation about the compatibility performance for a specific part, Shell is ready to perform detailed compatibility tests at our own labs if the parts are sent to our laboratories. Okay. So in this slide, we invite you to join the immersion work streams and contribute and details in the working documents, such as the immersion requirements and design for guidelines for immersion cooled IT equipment, and the material compatibility database working documents that we started to work on it can be found on the project wiki links displayed on the screen. So with that said, I would like to thank you for your attention, for joining this webinar, and would like to open the floor for questions and answers. Thank you very much.
Great, thank you so much, Eduardo and Sandeep. We will go ahead and begin the Q&A session. We have quite a few questions, so I'll just get started here. Our first question comes from Laura, and she asks, how is it possible that the water is 55 degrees Celsius hot, while when cooling with air in data centers, the air only gets up to 28 degrees Celsius?
Right. Maybe I'll begin. So begin on it. Although this would have been a perfect question for Asperitas to answer, but in short, what is in very simple terms, what's happening is because the electronics are immersed in the fluid, Asperitas optimizes the electronics to perform in a way that then this heat sort of that is generated, then it's only using convection currents to actually circulate. So actually then the whole system is optimized in such a way that the amount of heat that is collected, that is able to reach that temperature differential, or that delta T, to then generate this 55 degrees hot water. Yeah, that's how I'm just putting it in very simple layman terms, but I don't know, Edu, if you want to add anything to that.
No, I think, as I mentioned, Sandeep, it's a question I think was more related or it was Asperitas, but the delta T, it varies between 15 and 20 degrees Celsius, as I remember from their design. But the interesting to mention that they specifically place the IT components, I mean, immersed in a like I would say their chassis, and then they specifically place the hottest, the parts generated the hottest, the high amount of heat in let's say in the bottom of the chassis, and then you have to allow this, let's say this convection, natural convection circulation of the fluids. And then if you are interested in more details, I can recommend, because during the OCP Engineering Week, the CEO from Asperitas presented. There was a presentation, and then there was a pack, and I clearly remember there is let's say a slide specifically with of the module, and also with the gradient of the different temperatures. Temperature, water in and water out, and also you could have an idea about the change, gradient change during the, let's say, during the module functioning. So even if Ellie and Michael help me to note your name, and then we can point you straight away to this link after the call, and then I think you have a better idea about this, if that's correct. If you agree.
Yes, we can provide you with her information. Absolutely. Our next question, Khaled
Excellent.
asks, I presume your data center will still require fire suppression systems being installed, and what is the flash point of the fluid?
Right. Yeah, it's a good question, Khaled. Thanks for your question. So our flash point is 200 degrees Celsius, and you are right. I mean, each data center, and not only that, each data center, but each data center, depending on the location, we have to follow the standards of the buildings, and either according to local regulations or country guided regulations. So that's why, I mean, normally what happens, we work in cooperation with the integrators, with the companies designing the data centers. There's normally a company also helping this assessment, and then we provide all the information, not only the technical information, the physical properties like flash point of the fluid, and also the fire point, and also information related to that we can find in the MASDS, in the safety data sheet, regarding handling. And then this is also, everything is considered, but what we can see that's based on this flash point and based on the information and the purity of the fluid, this has been very well accepted for the design companies, and also helping to this in the new data center constructions.
Yeah, I'd just like to quickly add to that. So Edu correctly mentioned the flash point of 200 degrees centigrade. So this fluid was formulated with the OCP guidelines that were given to us. So we received what was the OCP requirement for immersion cooling fluid, and it actually exceeds the OCP minimum requirements.
Okay,
exactly,
great.
Sandeep. Thanks for. for the info. Yeah.
Our next question comes from Ebby, and the question is, I was wondering how the 30 to 45% decrease in the CapEx and OpEx is calculated. Sorry if I'm saying that wrong. What assumptions are made and what costs are included or excluded?
Right. So maybe let me take this. So there is a very detailed model that we use that actually Asperitas has developed, and that Asperitas runs, and it takes into account everything from the data center sort of whole build perspective. So it takes into account the primarily the air conditioning, and all of the other equipment that goes with that, and then sort of compares it on a one-to-one basis for an average data center. I don't recollect what is the PUE they use. Yeah, but that is sort of this is from the average global PUE. This number is given from, and again depends on the size of the data center, right? And so what at least I have seen from the different scenarios, the bigger the data center, the bigger the cost saving. So that's how you get to that that range. So the capex is comes from that. The opex, primarily what's happening is you are reducing your energy footprint by 50%, right? So when you're reducing the amount of energy that you're inputting into the system, and then you are also reusing the heat that's generated for maybe heating of the office spaces and so on. So then that sort of adds on to the opex reduction, and we are happy to discuss with you in detail. So if you have a particular a project that's coming up, then Asperitas and Shell would be very happy to connect with you, and then to work with you, and we need to test all of those assumptions and get some steer also from you, and then we can compare versus what you have in mind, what could be the estimated savings.
Great. The next question also
And also,
comes from...
Sandeep,
go ahead.
Perhaps just to complement, Sandeep, just crossed my mind. I mean, when it gets to capex and opex, the price, I mean, there are many variables, right? I mean, the price of the energy around the world is also different. But one point I think I'd like to mention, that's even considering the data centers, when you, one difference, I mean, that's why also the interest on single phase technology, and also specifically or single phase synthetic fluid, is because of the density. So the density of the fluid is very favorable comparing with other technologies. For example, if you compare with like a fluorinate, let's say, based fluid, and the density is really quite almost higher compared to our fluid. So the impact of this is that the data center itself has to consider, I would a lot of more reinforcement on the floor, for example, which may not be necessary for the technologies using our fluid because of the density. So this is just to give an overview how I mean this capex and also the cost reductions can be considered from case by case, and also considering which technology you are comparing to. Okay. I'm sorry, Kelly, I interrupted you.
No, that's fine. That's great. The next question from Khaled: can you put your hands into the fluid without protective gloves?
I can take this, Sandeep.
Yeah.
Yes, you can. You can, because just give you an example. And that's why I mentioned before. We particularly selected the the base oil, which is medicinal grade. That means that it complies with European, American pharmacopoeia's purity requirements, and also food grade requirements. It's just exactly to give this, to contribute with the safety aspects, give more confidence to the user handling the IT system and the module. Yeah, and then it's of course, I mean, to give an idea, this fluid is also used as in the cosmetic industry as a base oil for some, several applications, even some baby oils and creams. So you can imagine, I mean, the magnitude is. So yeah, it's you can do it.
Great. Richard asked, does Shell use this immersed cooling in their own data centers?
Yeah, I can take that. So we are actually in process of deploying our first.
You take that.
Sorry,
Sorry,
Edu,
go ahead.
Yeah, no, I was just mentioning that yes, we are actually in process of deploying our first deployment, which should be functional by February of next year. Yeah, so Shell is very much going to be using this for our own high performance compute applications.
All right. Ebby asks, what would you perceive the biggest challenges to bringing this technology on the market on a large scale?
Right. Maybe I'll start and then Edu, please add. Yeah. So I think
Yeah, sure.
probably the biggest challenge is it is something that is, let's say, relatively new, right? When people are used to air cooling, then it sort of comes across as a novelty. Although immersion, from what we understand, has been around at least for for the last decade. So it's been around for the last 10 years. But now there is really a focus on because of the high performance compute requirements and the growing need of data, and also the focus on climate change. So now there's really increasing focus on this technology that this could really help address the needs of increased performance and growing data usage while also reducing costs and being more sustainable. So I think the main challenge is for people to understand how it works, to see that it's actually a flexible solution. It's completely safe to do so. So typically what we recommend is test it yourself. Why don't you do a proof of concept? Put one server or two servers and monitor it and see if you're actually happy with the solution, and then you can actually get the confidence to move ahead to the next stage. So I think that's one of the main challenges, but then there are several others. So some of the other challenges, if we go down to, is from a standards perspective, right? So how do you how does the industry come up with standards? How do the OEMs understand those standards? How do the OEM electronic manufacturers manufacture products that are, let's say, warranted for immersion cooling? All of those different challenges are there when you go to much deep, when you go deeper. And that is also one of the reasons why Shell is at OCP, and Shell is actually participating in the ACS work stream, and also co-leading material compatibility work stream. So we are helping to at least our goal is to help to set those standards and to sort of develop this industry. Edu, please add if I missed anything.
No, I mean, you covered very well, Sandeep. I would only add, because from a technology perspective, as you mentioned, I mean, immersion cooling may not, I mean, is not new, right? I mean, it's been several years already there, but it's quite, I mean, talking to the people, you personally think is really quite disrupted, this technology, right? Because you're taking the IT part, you're taking everything that it was designed to work on air, and now put it in a model, fully immersion fluid. So it's kind of sometimes mind blowing, right? If you talk to people out of this business, if to them, they're only familiar with the standard, let's say, data centers, and you start to talk about efficiency, about immersion. It's the body language that this is quite still disruptive. That's why I think this is I would say is one challenge, but also I think is part of the journey. That's to bring I would say to make this technology more to bring awareness about this technology, right? As you mentioned, to bring awareness to it is safe, with this work, it's efficient, it's bringing us further. I mean, the customers and I would say the society as well through all the sustainability benefits. So and by by tackle this challenge different angles, as you mentioned, Sandeep, like collaborating through OCP, through multiple the major OEMs and big industry in this field, partnership. Making strong partnerships is also bring this sharing as much as we can on compatibility, and also this will help to in overall the industry to be more adopted by the customers, and also little by little I think this will get more traction, and then suddenly we'll have a much more greener or sustainable data center industry in the next few years.
Okay,
so
fantastic.
Yeah.
Our next question comes from Valerie. How could you ensure the high oxidation stability?
Okay, Edu, this is for you, but
right. Yeah. Thank you very much. So thanks for the question, Valerie. And so we, through the several tests we performed, right? I think the beauty of this, let's say, this this new fluid that is really because we developed with a very strong partner like Asperitas. So we had the chance to not only use our shell capabilities in the laboratories, because there are several different ways to measure oxidation stability. You can do accelerated tests. You can expose the fluid to different conditions and try to extrapolate this to see what happened. And but you can this one thing if you do in the lab, and the other thing if you do, let's say, directly in the model or using directly in the application. So we have done both in this case. So in the lab, we have some factors like the chemical structure of the digital molecule contributes for more stable, I would say, oxidation stability by itself. And also I would say, the fact that there is no, I would say, nearly, virtually zero sulfur or aromatics or any other compounds that would somehow react with any metal or with any component in the module, and somehow also to trigger some oxidation or some reaction that could eventually impact in the, I would say, in the fluid oxidation stability or fluid degradation. So that is also very, positive contributing factor from a fluid. So basically, to answer a question, we have accumulated several hours of tests in our labs through accelerated conditions using ASTM standards for thermal oxidation, and also live, on the R&D, let's say, laboratory from Asperitas, and the demo deployment working up and running. And if you would like to have any specific information about, I would say, the test or oxidation test, I think our emails will be available after the webinar, and then we can really discuss in details, about the test methodology, or whatever you need for further details. Okay.
Yeah, maybe just a very quick common layman pitch from me. So this is our bread and butter. Like Shell is known for developing world-class fluids. So we have specifically formulated this fluid with the help of Asperitas, for immersion. And so that's basically how we've engineered it so that it doesn't oxidize. And I think I do refer to the GTL technology also that we have used. So in very simple terms, how I describe it is, you can imagine. So this is not developed from crude. So there are no impurities in it at all. Basically, what we do, in my words, we take molecules and we take methane molecules and we put them together to make the molecule that we need. So almost you can imagine, you take Lego blocks and build sort of the toy that you want. So that's basically what we are doing in this technology.
Great.
Exactly. Thanks. And yeah, thanks for better words.
All right, our next question comes from Valerie again. What is the estimated lifetime of the oil?
So I can take this one as well, Sandeep. So based on the test we have performed, I mean, as I just mentioned, oxidation and accelerated tests. I mean, the oil itself, based on our tests, you can use the oil for more than 10 or 15 years. But the point is, I mean, based on the test acceleration that we have performed so far. But then we need to consider the multiple aspects. I mean, during the operation, right? I mean, that's I think this is the question. And also, I would say to answer your question, the oil really you can estimate to 10, 15 years, and now, but in this application, I think the oil is really not the point that we look for a change or would say, but the IT components, I think they are the ones where the technology is being really very quickly, let's say year by year, over you have better memories and CPU and GPUs, and then these components eventually will be changed way before than the fluid itself. So if you have to change the IT equipment every 3 or 5 years, for example. So this is where our baseline information, and that's and then this fluid can also, because additional to this, to make sure that the fluid is let's say performing accordingly or within the physical characteristics. We also have the capability to incorporate, I would say, equipment condition monitoring program. And what that means? That means that every let's say twice a year, or depending of the period the period that we determine, we can collect the samples and perform the analysis in our lab, and just to make sure that your oxidation stability is maintained, your acidity level is contained, can run a ICP or let's say inductive coupled plasma analysis to see if find something different in the fluid. But so far, really, that's what we developed so far. Right now, we can say that the fluid can last really longer in this application.
Yeah.
Anything from our side, Sandeep?
Yeah, no, I just wanted to say, so we have developed this fluid for lifetime of the server, right? So I would say lifetime of the server, and I would, and as I do mention, so we have not had, as you can imagine, we've just formulated the fluid and working with Asperitas for one and a half years, right? So we've not had the benefit of sort of testing it for 10 years. But we have methods to extrapolate that. So we believe, that the fluid will be perfectly fine up to 10 years, no problem at all. Definitely, 100% okay for the lifetime of a data server. And for added peace of mind, as I do mention, we are able to offer, also condition monitoring services, if that gives you added peace of mind, or for if you have any audit requirements and so on.
Mm-hmm.
All right, thank you. Our next question is, how much can you say about the sustainability of the fluid?
Okay, maybe I'll take that, Edu. So yeah,
Okay.
so this fluid is, as I mentioned, we take methane molecules and put them together and make the stuff that we want. So the methane basically comes from the ground. So it's not plant based, right? So I'm being very upfront right at the start. So it is coming from the ground in terms of natural gas. We take natural gas and then we make the molecule that we need. But in terms of sustainability, we are not adding to the CO2 in the atmosphere, because the fluid is not, we are not combusting the fluid, right? So we are not burning the fluid. It doesn't lead to any CO2 addition in the atmosphere at all. It stays on in the server module. It's completely, as I do mention, it's actually developed from medicinal quality base stock. So it's food safe. It's a so very pure fluid. It can be recycled, and we are actually also offering end of life collection and recycling services. Depending on for major projects and depending on the requirements. So that is part envisioned as part of our service offering. And also this fluid can be offered as carbon neutral fluid. So the small sort of CO2 footprint that is developed from manufacturing of the fluid can also be offset, and we have that also, as I showed in the triangle, our carbon credits solution. So in short, it can be it is basically can be offered as a zero CO2 fluid in itself, and will not add to the CO2 in the atmosphere.
Okay, our next question is, why partner with Asperitas?
Okay,
Well,
maybe you start, Edu. Yeah, take.
Yep, you
go
can
ahead.
start it. Yeah, no, I mean, this one I can talk about because I think, I mean, as we mentioned before, we really believe that cross collaboration between the industries is extremely important to bring us further, right? And what I would like to mention that through this collaboration, we also let's say Asperitas helped us to understand, the customer requirements and details specific about the immersion computing application and the materials conditions, the location where the modules will be also deployed. So this, because they are the experts, right, in this field. And now, so that's basically, I think, one of the key reasons that is really through collaboration and through this, this joining and collaboration, cross-business collaboration through different field of expertises. And then, in my opinion, Sandeep, this is one of the main reasons. If you have anything to add.
Yeah, no, I could just very quickly add. So, Asperitas actually won the Shell New Energy Challenge in 2018. That's a program that Royal Dutch Shell has, to identify, innovative, technologies and solutions, that can, help the energy ecosystem and, make the world a better place speaking very broadly. So since then, we have actually been collaborating with them, and then actually trying to take the solution and make it mainstream. So we really believed in their offering and in their solution. It sort of touched all the right boxes for us. In terms of our goals, in terms of sustainability, a really good quality product. Actually developed for high performance computing. So all of that sort of really aligns with our goals, and so we decided to partner with Asperitas.
Thanks, Sandeep.
Thank you. Our next question comes from Yves, and it is, at your level of experiment, where is the tipping point between traditional cooling and immersion?
Right. Okay. So maybe I'll start, and then Edu, maybe you can add to it. So I think I think it is sort of, I mean, that's a $1 million or $1 billion question, right? So I don't have a crystal ball, but I think right now since the last year and a half to we are really seeing growing interest in this from all the major participants, including the major hyperscalers, the major cloud service providers, just because it is now becoming imperative that people need to do something about climate change. Everyone has, all the major players now have goals in terms of how are they going to offset their carbon footprint, or net carbon goals. Shell ourselves, we have in the recent past announced that our ambition is to be a net carbon neutral energy company by 2050 or sooner, right? So and you see these goals now adopted by all of the leading tech players as well. So and then in when you look at the growing need of data, and that this solution now can offer sort of sustainable solution while also helping high performance compute and reducing cost. So there is a growing interest. So there are a number of proof of concepts actually that we are currently working with some of our partners on. Some of them have been very successful. Asperitas has recently made a few public announcements in terms of rollout of this at a few data centers on a full scale basis. Yeah, so it's I think that tipping point is probably coming closer and closer, but I can't say when it would be. We would hope that it's sooner than later, because we just think it is the right solution. It's the cleaner way. It's and there are all positives in it.
To add to this, Sandeep, I mean, just also from the technical perspective, I've seen the technology evolving so quickly on the the CPUs and GPUs suppliers, and then CPUs and GPUs 200 watts. I mean, which also require, I would say, a more efficient way of cooling, right? The technology itself is developing so quickly in this direction, and I think this is also another factor that will contribute for this development.
Thank you. The next question, sorry, I just lost it here. The next question is, how easy is it to deploy the immersion cooled servers, and how easy is it to do regular maintenance on the IT?
Okay, so this is more a question for Asperitas, and you can get a lot of information just by going to their site. But from my experience and from what we've seen, it's very flexible. So in the slides that we shared, you saw that black box. So that's basically one server module. So that can actually be deployed anywhere. It can be deployed in your normal office space. You could put a box in your normal office space, and it will work perfectly fine, and you'll see all the performance benefits. So it's very flexible. In fact, Asperitas has also done a few cases where they've put these boxes in a normal shipping container, and it was placed outdoors, and it worked perfectly fine. So it's a very flexible solution, but the main benefits will come when this is taken into account from a planning stage for a new data center build, because then you can actually plan the build in such a way that you don't need then the air conditioning infrastructure, all of the other associated infrastructure that is required for a normal data center, and you can also then engineer that for the waste heat reuse. Right? So then you really get the exponential benefits from this solution, but it can also be deployed in a normal data center. In terms of maintenance, so Asperitas also has products to do the maintenance in a very safe and hygienic way without any spills. So they have these products also that go along with their server modules, and then it can be done perfectly well without any issues at all. But they are the experts in for their servers. So yeah, we'll be happy to refer you to them, or you can get in touch with them directly, and I'm sure they'll be more than happy to show you how their maintenance products work.
Yeah, and just to add on this, Sandeep, as you mentioned, they I mean, on the maintenance bit, I mean, they have like a service trolley that's it's like a trolley that you can pull off this chassis and easy the maintenance when exchanging parts, and also with filter unit, and so this makes easier the maintenance and also the handling of the parts. I mean, when we're swapping some IT parts, so it's quite flexible as well.
Okay, great. We have time for one more question. Before I ask that to wrap up, I did want to mention that we will be providing Shell and Asparatos the list of all the questions we weren't able to get to, so they can reach out to you and answer any further questions that you may have. We really appreciate everyone's engagement. So let me ask our final question here as we wrap up. What is the role for Shell within OCP now that you guys are platinum members?
Do you want to take it, Edu?
I can take it, Sandeep, because I think now, I mean, it's really, as mentioned before, as a platinum member or as an LCP member now, we really have this opportunity to start really engage and collaborate more, I mean, broadly with the community, right? So this is, I think, one of the things has been really special to me. So as you know, we recently joined. I mean, it's been now officially in August this year, right? But we are able to actively be starting to get involved in the work streams and and really just to see how OCP and the synergy works with the different organizations. So this is I think the benefit, and also aligned with our strategy, you know, to help the society on the decarbonization pathway, find pathways, and also to help really to speed up this adoption of the immersion cooling solution. So this is the value really that I see, that we are now, I mean, mainly Sandeep and myself from our side, right, from Shell, but we really engage in Shell colleagues internally as well in every way possible. So I think this is a great platform, as a great collaboration, and then I'm really glad that Shell and ourselves are able to collaborate now.
Okay, thank you so much. That's all we have time for today. Just a reminder, the recording of this webinar and the slides from the presentation will be available on the OCP website under past events once we get this edited and ready to go. And like I said, I will forward any further questions or unanswered questions to the Shell Asparatos team so that they can reach out to you with some answers. And with that, thank you so much, Shell, for being here. Thank you, Eduardo. Thank you, Sandeep. We really appreciate your time.
Thanks, Kali.
All right, have a great day, everyone. Thank you.
Thank you very much. Thank you very much for everyone.
Thank you.
Bye-bye.
Bye-bye.